Hello everyone, a very good evening to you all. I welcome you all to the basic histopathology course, and this is the first lecture of the course in which we will be entering into the histopathology world. So this world of histopathology is going to be a very adventurous journey, and in this we'll be meeting many creatures, some of whom are known to us and some of whom will be unknown. So we'll be discovering and discovering these creatures as we move along this course. Now, in this journey, there will be a special someone who will accompany you throughout your life. So, this special person is going to be there throughout your life, and this is the person with whom you will be spending almost half of your day every day. So, let us meet this special someone. So, this special someone is going to be the Mr. Microscope, or I would say Mr. M, and this is the person with whom you will be spending almost half of your day every day when you will pursue this career. So before we move further in this journey, let us understand Mr. M so that we can pursue this journey in a beautiful way. This is Mr. M, this is Mr. Microscope, and these are the different parts which we will be using as we are going to focus the slides onto this microscope. So as we all are aware from our basic MBBS teaching that microscope comprises of an eyepiece, and then it has a nose piece to which the objectives are attached. Then it has a condenser, and this is the stage, and below the stage there is a condenser, and at the base of the microscope there is a light source. So this is the stage of the microscope where we are going to put our slides, and through those slides we are going to enter into this adventurous histopathology world. So let us understand some basic parts of the microscope before we move further. So this is the eyepiece of the microscope, and this is the dioptic diameter which could be adjusted from here. You need to make sure that the line which is there on the dioptic diameter is aligned with the zero on the base of the eyepiece, and then once that line is aligned, you are going to move your eyepiece inside and outside till the time you are going to focus a single image on your slide. So you need to adjust the eyepiece as per your convenience, as per your eyesight, till the time you see a single view of the slide on the microscope. And once you have adjusted the eyepiece, then you are going to look into these eyepiece with your glasses on. So you need not remove your eyeglasses when you are going to look into the microscope. Your glasses should be on when you go into it. The next thing that we have to be seen in the microscope is the slide stage, and at times the slide stage it is loose, so that when you change your objectives your slide focus will be lost. So you need to tighten the slide stage with the help of the knob that is given on the stage. Then we had the condenser. The condenser is there below the stage, and this condenser can be moved up and down, and you can adjust the slide focusing with the help of the condenser. Normally for all stained slides the condenser should be up, and then you can have a good contrast of the slide, but for all unstained sections the condenser should be down. Then once your condenser and your eyepiece are adjusted, then you can focus the image with the help of the coarse knob and the fine knobs. So fine focusing and coarse focusing could be done. Now below the condenser there is a diaphragm, like this is seen here, and from here again you can decide onto the light which enters into the slide and which is falling onto the slides. So if we move this diaphragm, if we close this diaphragm, as you see here the intensity of light is decreased, but the slide is illuminated in all the fields. The idea of decreasing the light of the diaphragm is more useful when you are looking at a lymph node and you want to assess the architecture of the lymph node. So when you want to look at the architecture, then your diaphragm should be in a low position so that the intensity of light is low and you are able to decipher the architecture in a better way. Now once you know the architecture, that it is nodular or it is follicular, you can completely open the diaphragm and look at the cellular details. So sometimes when you start doing your slide microscopy, your objectives will be little loose. So make sure that your objectives are in place before you start your microscopy. And if your objectives are loose, then if you change your objective from one to another, then in one it will be focused, while you come to the another it will be out of focus, like we see here. So this is a 4x which is well focused, but when we move from 4x to 10x, the slide becomes blurred. So you need to focus your slide, you need to tighten all the objectives so that you do not lose the focus of the slide. Then there is another source of light which is present at the base of microscope, and that is judging the maximum amount of light is coming to this halogen lamp which is attached here at the base. And this aperture which is there at the base of the microscope, it is going to decide the amount of light which is coming to this halogen lamp. If we close the aperture completely, then still there is a center part of the light which is visible on the on the stage. So like this is the area which is seen on the 4x, and if you see here, the edges of the field are cut. So we could not see the images at the edges of the field, and they are not showing adequate amount of lighting. So when you close the diaphragm, all this light is going to be centered at a single focus. So it is going to become a center focus like this. You need to make sure that your focus is in the center so that all parts of the field are illuminated, especially when you are looking at your slides at the 4x objective. So if you are looking at your slides at the smaller objective, your center part of the circle should be aligned in the center. So how do you align this circle in the center once your diaphragm once your aperture is closed? So you do it with the help of the knobs which are given at the side of the condenser. So you can adjust the knobs and you can keep adjusting them till your center part is there in the center of the field. So now we have understood Mr. M, and as I said, Mr. M is going to accompany us throughout this journey, and through him and through his eyes only we will be able to look into different adventurous animals that we have been seeing into this histopathology world. Now once we have understood Mr. M, now we should meet Mr. M's family member, because each one of them, they play a very significant role in deciding what we are going to look at. So first and the foremost family member of Mr. M is tissue processor. Now this is the biggest machine in the histopathology department, I would say, if you do not have an automatic tissue processor. So this tissue, if you do not have an automatic staining machine, so this tissue processor is the area where the tissues are being processed after they are grossed. And then in this, the processing, the thing that is taken care of is to remove all the water from the tissue, and this water is then replaced by the wax. So the idea of doing this processing is basically to remove the water content from the tissue and to get it replaced by wax so that they can be easily cut under the microtome. So we do it in various stages, like you do it for the first 2 buckets, you do it in formalin so that the tissue is well preserved. Thereafter, the water content is removed with the help of increasing rates of alcohol. So that is called dehydration. Then after the alcohol, you dip the cases in xylene. And after xylene, the xylene is being removed with the help of the wax. So the final idea is whatever tissue we are getting for crossing and whatever we have crossed, the idea is to remove the water and get wax impregnated in the tissue so that it could be easily cut with the microtome. Now the next family member of Mr. M is the embedding machine, and this is the second step when we come in the processing. So in the embedding machine, as you can see here, there are 2 areas, one is the hot plate and one is the cold plate. So whatever tissue that has been processed in the tissue processor, which is a total duration of about 14 hours, the next day all the blocks are taken and they are taken up for making up the molds in the embedding machine. So in this embedding machine, the tissue that we have processed, we will take them out from the cassettes, and then we will pour some molten wax, this molten paraffin wax over them, and we just fix them onto the block on the lower surface of the block. So we will do it like this. The tissue is being taken out from the cassettes. Then this tissue, we will pour some wax in the mold, and this tissue is aligned in the bottom surface. So we'll press it so that it comes near to the surface, and all the surface which will come near to the cutting surface of the microtome. So it will be a smooth alignment. So we just press it little, like we could see here. So it is little pressed, and then you put the cassette over it, and then it is kept with after some pouring of the wax, it is kept on the freezing chamber, that is the cold plate. And on the cold plate, this will get fixed. So you can easily take out the block and use them for microtome cutting. Now this is the third member of the family of Mr. M, and he is Mr. Cutting Microtome. Again, a very important machine that we use in the histopathology department. So in this, the molds that we have formed in the embedding machine, they are being cut by putting the blocks in the tissue in the block holder. The normal section thickness that should be cut in the microtome is around 4 to 5 microns. So that is very important. If you are taking thick sections, then you will not be able to decipher the cellular details properly. And if you are doing specialized reporting like for liver, like for kidney, then you need to do your cutting even at a lower micron. So you need to cut it at 3 to 4 micron also. So that is your rotary microtome. And this is how the microtome works. Like you put the block on the block holder, you cut the slide with the help of a blade, and then you take a ribbon. Then you float the ribbon on the water bath, which is later on taken onto the slide and was taken further for histopathology staining. So now we are now acquainted with the family members of Mr. M, and we now know that there are different members in the family. So in this family, we are knowing them is not enough. So it is not just enough that we know their names. It is also important that we understand each one of these persons, so that there is no problem when we do our routine histopathology reporting. So knowing them is simply not enough, and we need to understand them so that things go better as we move along. So what will be the problems that can arise? So there could be a number of problems. They could be pre-analytical. So major categories in which we can divide the histopathology problems are pre-analytical, analytical, and post-analytical. Pre-analytical is till the specimen is received in the lab. So till the time you are doing your processing, all those steps are pre-analytical. From the OT to the sample coming into the lab, or from outside if it is coming into the lab, the numbering that is there, the patient name that is there, they are all pre-analytical issues, and whether or not the sample is received in formalin is also a pre-analytical issue. Now once you have identified the specimen and you have crossed the specimen, then comes your analytical part, in which we will process the tissue, and the processing part is being taken care of by the technical department. Now once your slides are cut, then it is being shown to a doctor for analysis, and this is where the competency of a doctor will come, and these are the post-analytical parts. So now the first and the most important area is know your areas first. So as a doctor, our job starts when we enter into the grossing room. So grossing, I would say, is an art, and it is gradually learned when you do a number of grossing specimen. But there are certain basic things that are to be followed for whatever specimen you are grossing. So we will look into those areas that are to be followed for most of the specimens that we gross. So suppose we have an elliptical specimen like this, and this is the lesion which is seen on the surface. So there is always a dilemma: how should I cut it? Should I cut it like this horizontal, or should I cut it vertically into serial slices? So how should I cut it is a common sense question. The thing is that normally if the lesion is in the center, you should cut it on the surface where the exposure of the surface will be maximum. But if your lesion is near to one margin, like here the lesion is near to one resected margin and near to one lateral margin. So in those cases, I would like to cut it in a transfer section, so that I can take sections from here. I can take sections of the lesion with the closest resected margin, and then I can also prove the distance of the lesion from the closest resected margin. So if you are getting an ellipse, or if you are getting a wide local excision specimen, WLE specimen, make sure that you should cover the area where the lesion is closest to the lateral margin, and then you cut it serially in whatever fashion you have cut, and you look at the area where the lesion is closest to the deep margin. So before you cut your specimen, it is wiser to ink all the entire base of the specimen, so that the ink gets imbibed on the base, and when you take sections from the base, you can tell the distance of the lesion from the base of the lesion. So it depends. Suppose if the lesion would have been in a vertical fashion, then we would have liked to cut it in the serial slices, vertical slices like this. So now it is important for the tumors that some of this some terminologies that we use, whether lesion is well defined, ill defined, circumscribed. So if I say for this lesion, if you are able to make out the boundaries of the lesion, then it is a well defined lesion. A well defined lesion can be uniformly smooth. It could be uniform surface. The color, you need to tell whether it is similar to the color to the adjacent parenchyma, or it is of distinct color. Generally, we do not use the term the bright colors. We do not use in histology. Most of the times we will use it whether it is grey tan, whether it is grey white, or it is greyish yellowish variegated. So these are the color that we use in histology. And then in addition to the color of the tumor mass, we are going to tell the consistency of the tumor as compared to that of the normal parenchyma. So we need to tell whether it is soft to firm, or it is hard in consistency. Now when we know the consistency, the color, then you have to tell about the shape of the lesion. So whether it is well defined, ill defined. So all these three things together are going to tell you whether this is going to be a benign lesion or this is going to be a malignant lesion. So these are the three things that are to be followed with all specimens and all lesional material that you see on your grossing. Now this again is a well-defined specimen. This is a well-defined tumor margin, and from the description itself, I would say that this is grey tan in color, and this is also showing a lobulated pattern as opposed to the previous one which was having a smooth cut surface. This is showing a vague lobulated pattern, but the margins are again well-defined. So when you describe a thing like this, it again shows that you are talking of some benign etiology. Now, another area where you could see that this is again in well-defined lesion, but in this lesion, you see that the margins are lobulated, so there is partly lobulated contour to the external boundaries. But in addition, you also see that this is not a smooth surface, and this is showing multiple nodules within the lesion. So you can say that these are multiple coalescent nodules within the tumor mass that we are seeing. It is whitish in color and it has got a lobulated outer surface which is relatively well defined. So that is the different terminologies that we will use, and we will tell whether or not it is firm or soft in consistency. Now another lesion, if you see here, so in this lesion, as we could see, the margins are not well defined. So the lesion is relatively ill defined. In addition, the lesion is showing partly lobulated architecture or not partly nodular architecture, and in addition it is also showing some areas of hemorrhage and necrosis. So when you see a tumor which is showing lot of this hemorrhage and necrosis, then the term that we commonly use is that the tumor is showing a variegated appearance. In this, you can say that there are grey white, predominantly the tumor is greyish yellow, grey white in color, and with areas of hemorrhage and necrosis. Again, for like mastectomy specimen, so we had a tumor here, and in this specimen we could not really make out what are the boundaries of the tumor. So we will call this as a relatively ill-defined tumor mass which is merging with the adjacent structures, and you really could not make out the boundaries. So that is in itself going to tell you that this is some form of malignant tumor. So now when we know the different phases of the tumor, and now we have talked of how you should approach to these specimens, the next important thing that comes in grossing is inking of the specimen. So how I should ink the specimen and what inks should I use? So the first is, if you are seeing a small biopsy, when you put them on the tissue paper, put some drops of eosin, so that when the technician is going to do the embedding part, these bits are easily identifiable. So all the small bits, put some drops of eosin on it, so that they could be easily identified at the embedding area. Now for the larger specimens, which are removed en masse, like if you have a soft tissue tumor and the entire en masse tumor nodule is sent to you, it is advisable that you ink the entire outer surface. So the entire outer surface has to be painted black with the India ink. Or if you are getting an ellipse of skin, or you are getting a WLE specimen, wide local excision specimen, then it is advisable that you ink the base of the specimen. And if you have the lateral resected margin, you ink the closest margin that is visible to you. Otherwise, like for the specimens in which you have only one of the near margin, like CRM, circumferential margins in colon tumor resections, so you can just ink the area where you think that the tumor is closest to those margins. For soft tissues, generally we ink the entire outer surface. And for the breast and for skin resections, generally the entire base of the mastectomy or entire base of WLEs are inked. Now there are certain specimens in which you need to ink with different colors the different facets of the tumor. Suppose this is a prostatectomy specimen, then you would like to use different colors. The common colors that we use are the camel poster colors, and you can use these colors to ink the different surfaces of the prostate tumor. These two inks are also used when you wanted to color different surfaces, like in pancreatic resections, in Whipple resections also. So the idea of doing a grossing is you should understand how the tumor is looking like, whether it is looking benign or malignant, whether you feel that the tumor is looking as a complete surgical resection or not, and then you should also take the microscopic photograph. So it is always advisable that if you are doing the resection of a larger gross, you should take microscopic photographs. Then before we going to cut that specimen, it is also advisable that you read the TNM criteria. So you should go through your CAP protocols if you are going to resect any tumor resection, so that you know what are the things that are important and what are the things that you need to give emphasis on. So like if in case of breast carcinoma, if you are going, so if you have read your TNM, you know that the size that is going to matter it, whether it is 2 centimeter or it is 2.1 centimeter. So if you make it just a 0.1 centimeters high, it is upstage. Similarly, like for kidney resections, if you just change the centimeter size from 7 to 7.2, it is upstage. So if you have read your TNMs carefully, then you should be more wiser in calculating the size of the tumor, and then you will be more wiser to look into those areas where those will be important from the protocol point of view. You should ink your specimens as we have discussed, and inking we have already mentioned. Now see a specimen like this. So if you have a specimen like this, now in this tumor, as we could see, again partly lobulated at the external surface, but it is relatively well defined. Now in addition, how to measure the tumor size? So there are two ways to measure. Either you measure from this end to this end completely, or you measure from this to this, or should I measure diagonally like this or like this, or should I measure vertically like this? So they say the size of the tumor should be measured in the maximum extent of the tumor. So any dimension which will give you the maximum extent of tumor, like in this case it is the horizontal diameter that is maximum. So this is the diameter I'm going to measure for one of the diameters of the tumor, and the other diameter is this one, and then the third one is going to be a three-dimensional diameter where you will see the width of the tumor. So like for this particular tumor, we have two distinct nodules. One is seen here and one is also seen here. So should I include these nodules in this tumor? No. So they say that if the nodules are distinct, they are to be counted as satellite nodules if they are within 2 centimeters of the main tumor mass. So you're going to measure the size of the main tumor mass, and the smaller ones you are going to just mention that there are several separate satellite nodules if they are within 2 centimeters of the main mass. So you have to measure the size of the largest tumor mass that you see. So now the next question that arises, what is the optimum thickness of section that I take? So whether I should take 2 into 1 centimeter or whether I should take 1 into 1 centimeter. The ideal thickness, the size of the tissue should be 1 into 1 centimeter. So it is like a square of 1, and then you cut it into 1 into 1, and the thickness should be less than 6 millimeter. The idea that we are taking a smaller thickness section is so that formalin can penetrate adequately in that. So when they cut their sections, the tissue is appropriately fixed. You can take larger sections in cases if you want to, for like certain areas where you wanted to see the relationship with the different perspectives. You want, like in the Whipple's resection, you wanted to see whether the relation with the duodenal mucosa or with the pancreas. So there you can take larger sections provided you have taken thin sections and they're adequately fixed. Now once we are over with the grossing, once we have understood grossing, now the next thing is, after processing, when the slide comes to you, there could be several problems with the slide. So when you are looking at the slides, you see that the section is not good. There are many folds in the section. Then there could be bubbles. There could be labeling artifacts. The slides could be dirty. So then you go back and ask your technicians where the problem was. So before you go back and ask your technician, let us see where all the problem can arise. So like this is one of the case from the same biopsy of a liver tissue in a child, and these are two biopsies. One is received in formalin, one is received in normal saline. As you can make out, a biopsy which is received in normal saline is completely autolyzed. You could not see any cellular details here, and it is not possible to tell about the degree of inflammation or the architectural pattern over here. Whereas for the same biopsy which is received in formalin is a very well preserved biopsy. So you can make out that the tissue is all adequate and you can decipher the cellular details here. Then sometimes when you have got a new technician in the department, they can do wrong embedding of the tissue. So you do a grossing of a gallbladder and you are only seeing muscle, or you take sections from the cyst wall and you are not able to see the lining epithelium. Go back and see how the technical staff has embedded the tissue, or ask them to melt the block and then do the re-embedding. So there are the cyst wall and for the gallbladders. Then there are certain specimens like muscles and skin for alopecia. Those are to be embedded in a different way. So you should know how to embed those tissues, and therein you want the entire surface, that is the mucosa muscularis. So they should never be embedded in a standing position. They should always be in a lying down position where you could see the mucosa, muscle and all the layers. And for larger tumors, you can give the maximum surface on the side of the mold where you want the cutting surface to be. Now, if your microtome blade is not good, if your microtome blade is poor and they're repetitively using the same microtome blade, then this is what that could happen. You take ribbons and the ribbons are cracking in between. So this is the problem that can arise if your microtome blade is blunt and you are not using a new blade, so you do not get a proper ribbon. And then in addition to these, you will also get many folds on your section. So these are the folds that could arise from a blunt blade, and these are the folds that could also arise if your block is not kept on the freezing part of your embedding table. So ideally, before cutting the block on the microtome, you need to freeze it so that the section becomes very clear and there are no folds on the section. So these are like two tissue sections which are taken. So one is with the normal blade and one is with a blunt blade. And as you can see here, there are many folds which are coming in the section because of that blunt blade. And when you look at microscopy, so this is the time when you go back and tell your technical staff that your job is not perfect, and this is how it is going to look like. So there will be cuts in the section, there will be folds in the section, and then you can tell them either you are using an old blade or you are not freezing your blocks properly. So the folds will look like this. So there will be curling up of the section, and at times you will see that the blocks are very hard. So sometimes they are going to come to you and say that, oh my god, this block could not be cut and it is very unfixed. So this is how an unfixed block is going to look like. This is a block which is unfixed, and if you see here, it is very hard and brittle and very difficult to cut, as opposed to this block which is a relatively well preserved block in which we could see the entire section. So if you cut a block which is not adequately fixed, this is what is going to happen. The ribbons again are going to crack, and you will see large defects in your section. Now, if your microtome thickness is not proper, if you have not adjusted it properly at 4 to 5 micron, you will get thick sections, and thick sections are a very big problem when you are doing a lymph node pathology. So you cannot tell whether the size of the cells is small or it is larger unless you take a thick section on a lymph node. The staining again could be an issue. You could have a lightly stained slide, as we could see here. The nucleus is very indistinct as opposed to this where the nucleus is brightly hematoxylate. Now once your everything is over, then you are going to go back and look into your slides and do the assessment of the slides. So this is the area where the competency of the pathologist will come, and this is the area where we are going to look into the slides and see and tell them what is normal and what is not normal, what is a contaminant. So all those things that will rely on the competence of the pathologist. So like if you see here, this is a slide area, and if you see, these are the areas where you could see that this is something abnormal which should not have been there for a normal tissue, and these are all suture materials. So if you have not removed the threads from your material, you ought to get these suture materials. So they could be of different colors like black color or they could be white color. The only thing that you can tell is they have no nuclei. So most of these will be like anucleated cells, and not cells, actually they will be seen as sheets in the slide. So you will be able to identify that these are all suture material. Sometimes you do see vegetable material when you are looking at the gastroluminal biopsies, and at times these luminal vegetable material, they look like parasites. So the important point to identify them is that they are not parasites. And how do you identify them? You look at the reaction in the surrounding mucosa, and if there are no eosinophils, that tells you that most likely these are plant cells, and the cell wall is also going to be thick. So that is another way to identify them. Now this is another area where sometimes you will feel that this is the pathology, but this is actually not a pathology. This is a gel foam that is usually seen when you take biopsies and you pack the material with a gel foam, and at times you get those gel foam on your slides also. This is how it is going to look like. So it is just an artifact and it is not a pathology in itself. Again, an area which is showing necrosis, and over the necrosis you are seeing these hematoxylific bodies. So sometimes you will say that the hematoxylin is not properly filtered, but actually these are not hematoxylin bodies. These are actually the debris, cellular debris, which are seen in addition to the necrotic material. And then this is a beautiful slide which is showing an asteroid body here within a giant cell. So we know that asteroid bodies are generally found in sarcoidosis, but it is not the only thing. So we should be aware of the other areas where the similar things are found. So if you see an asteroid bodies, you should not jump to a diagnosis of sarcoidosis. And these are still these are common findings in other giant cells also. And this is asteroid body in a case of foreign body giant cell reaction. So there could be contaminants, there could be common things which are seen at an uncommon place, and you should be able to identify the normal things at those areas. So I would say with this, I would conclude this with the 7 gems of histopathology. And the 7 gems for the introductory session of histopathology will be: know your subject. It is very important to know what I am doing, how I am doing, and why I am doing this. Always keep asking yourself why, and that is the area, that is how you're going to learn histopathology throughout your life. A proper fixation is a must. So if you are getting autolyzed specimen, that is not your fault and you can't do much about it. Appropriate size section is very important. So if you are taking very thick sections on your grossing table, then you might end up seeing a unfixed tissue and you will miss on to certain areas. Appropriate thickness again is very important. Gross well, you should ink all the areas, mark the lateral margins, mark the, even if they are not tagged, you should be able to identify which is the closest lateral margin and what is the distance, so that at least they get an idea that the tumor is reaching up to the lateral margin or to the base of the resection. Know the contaminants. Know if you are looking at certain areas like GI, if you are looking at certain smaller biopsies, you should be aware of the common contaminants that can come from the surgical procedures. At times they take gastric biopsies, and those, if they're using the iron forceps, you get some iron granules on the surface. So that is not equivalent to an iron pill gastritis. So those contaminants you should be aware of, and then unless they are causing some pathology, you should just ignore them. Know the normal, that is very important. You should be aware of what is normal so that you can identify the abnormal easily. So with this, I think we conclude our session here, and this is just an entrance into the histopathology world, as I said. And in this journey we will be accompanied by a number of persons, and we have already met the family. So the most important person who will be accompanying you throughout your life is going to be your microscope. So always understand Mr. M, and then you will be having a happy journey altogether. Thank you so much. This is our first step towards the entrance into the histopathology world. And I know that first step is always the hardest, but once we are over this step, the success is going to come for sure. So once again, I thank you all, and I look forward to any questions if there are. So thank you once again.